Welcome to CHEMBLAST. So this is a video recorded to explain on how to attempt question 1 in chapter 2. Okay, let's look at question 1a. So it is given an equation like this, and they ask us to determine the enthalpy change for this reaction. We note that all the value given actually is in the form of enthalpy change of formation. Now we can use the equation, which is involving all the enthalpy change of formation. So this equation is known as delta H reaction equal to summation of delta H formation for all the products minus summation of enthalpy change of formation for all the reactants. So how to use this equation? So you need to recognize who is the products here. So in this equation, there are two products, which is written at the back of the equation, and there are two reactants written in the front of an equation. So why do we need to times 2 in this equation? Because there are 2 moles of nitric acid in this equation, so we have to times 2. Whereas there's nothing written here, means it is 1 mole, so we just leave it as is. And 3 moles in NO2, and water is only 1 mole. Okay, so let's substitute the value from the question. So HNO3 has an enthalpy change of formation of -207, and for NO, the enthalpy change of formation is +90. So we substitute all the values in, and we try to calculate it, and the answer is -140. Now the unit should be in kilojoule and not kilojoule per mole. We only use kilojoule per mole when it is a reaction that we can give names like enthalpy change of atomization, enthalpy change of combustion, and so on. So if you look at this question, this is just a reaction without any specific name. So we will leave the answer in the unit of kilojoule. Now for question 1b, it is about a question of bomb calorimeter. So we are having benzene C6H6, which is 1 gram of benzene, burned in excess oxygen to produce carbon dioxide and water. And the question asks us to find the temperature change. Temperature change is delta T, and it is given the heat capacity. Heat capacity is C capital for a calorimeter, which is equal to 5.86 kilojoule per degree Celsius. And we are given the amount of delta H for 1 mole. For 1 mole of benzene burned. But we need to know how many mole is actually burning in this scenario. So to attempt this question, we need to have some tips. So first thing, we need to find the number of moles of benzene given. So we are going to apply the formula mole equal to mass over molar mass. Okay, and then after we find the mole, we can find the heat release, which is Q. That is involved for the particular of mole in this question. And then after that, we can relate Q and delta T. Okay, Q and delta T using the formula Q equal to C times delta T. C here is the capital C, which is heat capacity. Okay, so let's find the mole first. So mole of benzene, the mass is 1 gram, divided by the molar mass. So C6, so C is 12 times 6, because 6 carbon and hydrogen is 1 gram per mole, so times 6. So we will obtain the number of mole, which is 0.01282. Then we try to calculate the amount of heat released by 0.01282 mole. So we know that from the question, if 1 mole of benzene, it will release the 3264.6 kilojoule. Hence, if we only have 0.01282, it will only release 41.854 kilojoule. Or we can use this equation if you still remember, we have this equation delta H equal to Q divided by N. So if we want to find Q, we just multiply the delta H with the N. So we can have more times delta H, which will obtain the same answer. So both methods are accepted. And this is the equation. We can relate Q with delta T, because we know that all the heat is actually absorbed by only the calorimeter. So we can use Q equal to CAT, C times delta T. So what is the amount of Q? Q is 41. So just ignore the negative sign because we just want the value of heat release. And C is the heat capacity from the question, 5.84. So we can find delta T. Delta T is 7.14. And let's answer the question. The question asks what is the temperature change. So we just write that temperature change is 7.14 degrees Celsius. Now for question 1C, we are asked to construct an energy cycle diagram. For the dissolution of lithium chloride. Dissolution means dissolve. Salt dissolve in water. So this is water, H2O, and we are asked to find the value of X. X is the enthalpy of hydration of lithium. So let's have some tips on how to construct an energy cycle diagram. So the first thing, we need to write the equation for the dissolution of lithium chloride, and then we try to write the equation for the lattice dissociation for lithium chloride, and then lastly we are going to write the equation for the hydration of lithium and chlorine ion. Then we are going to connect all the equations. Okay, let's start with enthalpy of dissolution. So dissolution means solid. Salt actually dissolve in water to form aqueous ion, and the enthalpy given is actually negative 37 kJ per mole. And this is not a very straightforward reaction because it actually needs two steps to happen. So the first step, we need to split the solid ion. This is positive and negative solid ion. Actually they are in a big lattice. So we need to split them up. So we need to provide energy. Is needed to separate them into gaseous ions. Gaseous ions, they are very far away from each other. But we see that in this question, the enthalpy for lattice actually is a negative sign. Negative sign means energy is released. So for this process of solid changing to gas, we have to make sure it must be changing the sign of negative to positive 846. Okay, so remember to change the sign to positive sign because this is a process that needs energy. We need to absorb energy in order to split up the ion into a gaseous ion which is very far from each other. Okay, then hydration of lithium plus. So hydration means changing gaseous ion to aqueous ion. So the value is X, which is something we need to find. So we put it here. And then hydration of chlorine ion is negative 373. So how to relate that? So we can actually look at the sign of the direction of the equation. So there is one equation that is in clockwise direction, and we have a few equations. So this is a different direction. So these are in anti-clockwise. So we can use this equation. Delta H solution, which is in this direction. Delta H solution is equal to enthalpy of lattice plus enthalpy of hydration. So we put in all the values. So this is negative 37 from the equation, and positive 846 plus X plus negative 373. So we just do a simple calculation. X is negative 510 kilojoule per mole. So this is the answer for the value of X. So we have come to the end of this video. So thank you for your attention. We hope that this video will help you in attempting the question in this program. Thank you.